3, Lesson 3, Arithmetic and Geometric Sequences. So there'll be one instructional outcome we're really going to focus on this time, and that is to examine the structures of arithmetic and geometric sequences. In other words, in class today, you're going to see a series of sequences and you're going to have to decide whether it's geometric or whether it's arithmetic. We talked a little bit about these two sequences in Lesson 1. So if you wanted to look at some of that again, you could, where we said arithmetic was either add or subtracting by the same number each time. And geometric is when we are multiplying by the same value each time. So really, when it comes down to it, this is the one exercise that is in Lesson 3 that needs to be understood. So it says, examine the following sequences, classify them as either arithmetic or geometric, and then provide evidence for your assertion, and then write a formula for each of the given sequences. And so we'll probably write a few of them just to give you an idea of how to write them and so forth. But if we start to look at some of them, make a decision. And so if we looked at, for example, this one here starts with -2 and then 2 and then 6 and then 10. And so you might notice with this one that we are intending to add 4 each time. So +4 and then a +4 and then a +4. So the students might think, well, gee, I think that might be arithmetic. So we can drag it in and see. And if it sticks, it'll be arithmetic. So let's say it's not. Let's say it's geometric. It didn't stick. And that would be appropriate because the students in the class should be thinking that this is an arithmetic sequence. So if I wanted to write a formula for that, well, the first term happened to be -2. We knew that the common difference was that I'm adding 4 every single time, so +4 and then n -1. And again, we can leave it like that, or the teacher may ask the student to distribute and combine like terms, but this is an acceptable way to turn in your answer as well. So if we looked at the one right underneath it, 2, 4, 8, 16, we note that how do we get from 2 to 4? Well, we add 2, but if we're adding 2 here, we don't get 6, so we know it's not arithmetic by adding 2. So I could try a different perspective. I could say, well, what times 2 gives me 4? Well, 2 times 2 is 4. And 4 times 2 is 8, and 8 times 2 is 16. So we know that this one is geometric. And so if I wanted to write an equation for that, the first term is 2. I am multiplying by 2 each time, and I raise that to the n -1 power. So what I would probably recommend you do at this point in time would be to pause this video, look at the last 4 by yourself, and see, can you come up with whether it is arithmetic or whether it is geometric in nature. And then when you think you have it, take a moment and then unpause the video and then come back to see whether you are correct or incorrect for your assertion. So to follow up, here we have an arithmetic formula because every single time we're adding by 1/2 or 0.5. And the next one, 1, 1/3, 1/9, 1/27, that would be geometric because we're multiplying by 1/3 each time. So the respective sequences for each one of these, if this one was arithmetic, the first one in the sequence was 1/2. I am adding 1/2 every single time, and I'm going to multiply that to the n -1. For this geometric one, we noted that we are multiplying by 1/3 each time. So the first number was 1. We're multiplying by 1/3, and we're going to raise that to the n -1 power. For the last two, the 10, 1, 0.1, 0.01, that is going to be geometric. The formula that will go with that is the first term is 10. We are multiplying by, depending on how you want to write it, 0.1 or 1/10. 1/10 or 0.1, however you prefer to write it, and that's raised to the n -1 power. And the last one, 4, -1, -6, -11, we are subtracting by 5 each time. So my first number is 4. I'm subtracting by 5 each time, and I'm multiplying that to n minus 1. So again, just to summarize the lesson, two key features to understand here is an arithmetic sequence is a sequence called arithmetic if there is a real number, d, which is our common difference, such that each term in the sequence is the sum of the previous term. In other words, we're adding or subtracting by the same value every single time. Geometric sequence is called geometric if there is a real number r, that's our ratio, the number which we're multiplying by every single time, such that the product of the previous term is the r in that given case.